Alright, still I'm trying to find some good distance. It seems like my voice get really high pitch again whenever I don't know, even slightly change the distance. So sorry about that, folks. We all learn as we experience some new things, new technology and so on. Long story short, and I'm gonna try it better. Hopefully it doesn't have a lot of noises, those kind of situation. Right now what we're going to do is, we're going to do second example, which is like explosion situation where every momentum cancel each other just because it was on the rest. Let's read the question together. A cannon with a total mass of 60 kg is initially at rest. If it fires a 1.5 kg cannonball at 420 km per hour east, determine the recoil velocity of the cannon. So, I draw some good cannon diagram in here while I took the image off. Here's something that I want to highlight first. Initially at rest. People who had my Physics 20, this is actually giving you a lot of key clues. The reason being is, at rest is a fancy way of saying velocity is zero in terms of physics world. So, let's see. That means, again, think about our first step. It's setting up an equation. In this situation, we're going to do similar way. My initial momentum, sum of initial momentum, is equal to my sum of final momentum. Now, in this situation, my initial momentum is zero, just because, again, initially everything was at rest. Now, that means if I look at the second momentum situation, I have my one of the object, which is a cannon. Let's say 1 is cannon and 2 is cannonball. Oops. I spell cannon as cannot. Anyway. So, that means somehow my number 1 object momentum and number 2's object momentum has to be cancelled out, because mathematically, if I move one of the object to the other side, you will get to a situation where my one of the momentum, another momentum, just a quantity way, they should be equal each other. In terms of actual vector, they're opposing each other because they're having such a different direction. Now, let's write down some of the clue that is given, which is our second step. We have our second mass given, which is cannonball, 1.5 kilo. At least good thing is we don't have to change our unit into kilogram, unlike the previous one, except probably some people say it's even worse. We have kilometer per hour. Now remember from Physics 20. Kilometer per hour has to be changed into meter per second most of the situation, especially when we deal with any dynamic situation where Newton's laws occur, because the concept of force, which is mass time acceleration is meter per second square, and we define those two's combination as Newton as a unit. Now, similar in here too. Momentum use Newton inside. We learn about impulse and how force can be involved in terms of change of momentum. Let's look at this situation, V2. Well, since we have kilometer per hour, what we can do is time by 1000 divided by 3600 in order to make it into meter per second. We can actually start by doing this unit conversion if we have any chance. So, 420 times by 1000 divided by 3600 can give you 116.6666666 and keep going. Generally, in my case, I use a, well, special hat, which is we use it for repeating decimal places, and just list them. So 116.6 meter per second. Do we have another clue? Yes, we do. We do have mass of our cannon, which is 60 kilogram. And our goal is to try to find our final velocity of the first object, which is cannon in this case. Now, we need to substitute, we are in still second step where we're basically putting our formula in. As you may notice, it's a mass times velocity again, except we need to isolate for v1. Easiest way we can do is divided by a variable that you don't want, which is our first mass. So if I rewrite this expression, you're going to end up having v1 is equal to negative m2 v2 final velocity divided by m1. And now this is our last step, which is substituting in. When we substitute things in, we always be careful with the sign, or be careful with our number, bracket, those kind of mini steps. Talking about direction, we didn't decide which way we go, positive or negative. This time, why not? We decide left as positive and right as negative, so that in terms of our answer, we can get the quantity and direction at the same time as positive number. If you are somehow OCD that you have to decide anything goes right as positive and everything goes left as negative, feel free. Not gonna stop you. So 1.5 kilogram times by 116.66666 meter per second. So since I say this number inside of my calculator, I can just use second function answer, which a lot of Texas Instrument type of calculator has, divided by our M1, which is 60 kilogram. Now, there's one thing that I miss, which is we just decided going right as negative, and look what happened. I forgot to put negative. See, mistake can happen all the time, right? That's why when it comes to physics work, you have to check double or triple. Now let's punch some number in. You should get again positive answer. 1.5. Previous answer divided by 60. You will definitely get less number. It's actually a little bit nasty number. 2.916666 blah blah blah. Now sometimes you can do a little bit of a concept check as a double checking method, whether you're on the right track or not. As you may see, the cannonball is going towards east, and as you may notice that cannonball's mass is really tiny compared to the cannon's mass. So when it comes to cannon, naturally, because it's heavier, it's gonna move slower. So if you did some kind of mistake in terms of your calculation, you should have smaller number instead of larger number, because it's natural logic at this situation. Heavier object, in order to move it, imagine you need to use the same force, it's gonna move slower. Imagine you're moving sumo wrestler with certain strength that you have versus you're moving a box. Anyway, the answer in this case, rounded up to 2 significant digits, is 2.9 meter per second. However, don't forget the direction. West or left, anything like that, you can use it. In our situation, it is west because, as you may notice from the question, instead of using left or right, it actually used east in here. So, there you go, folks. That's our lesson for our conservation of momentum in one dimension. Your homework is solve all of the one-dimension conservation of momentum questions given by my worksheet or work booklet, whatever the one you call. Thank you.